Ladies and gentlemen, everybody is aware of Cape Electric, and as I said in the beginning, the continuation of sharing knowledge is the passion of Mr. Gopakumar, who's heading this Cape Electric, which is established in 1996. Cape is the first and front runner in various technology products in India, be it lighting protection or electrical installation materials. Cape technical seminars and webinars on lightning protection not only help industries in solving failure related to lightning, surges and earthing, but gave an in-depth knowledge about international standards. Providing solution is the motto, and hence the technical team in Cape Electric are continuously trained to provide end-to-end solution from design to implementation. I don't need to talk much about Mr. Gopakumar. Our keynote address, Dr. Agar already spoken about Mr. Gopakumar, and he has become a face of electrical vertical in the country. Anything related to electrical, it's all Gopakumar. So he's a strong member of National Building Code. He's a member of international committee. So what more? So I won't do this much detailed introduction of Gopakumar because you don't need Sachin Tendulkar need to be introduced in cricket. So it is like that, Mr. Gopakumar in electrical industry. Over to Mr. Gopakumar.
So thank you very much, Mr. Dominic. I hope my screen is visible.
Yes, sir.
So thank you very much, Mr. Dominic, for your encouraging words. Also, thanks, Dr. Vijay Agarwal, for giving the keynote address. Today, we are going to discuss about hospitals and safety, not only fire, but the general safety in the hospital. The hospital safety worldwide, the mandatory rules of hospital safety has been made in the IEC standard 60364, part 7710. It's actually a part of the IEC standard called as 60364, electrical safety. Worldwide, across the globe, this standard has been adopted in Americas, in Europe, or in all the developed nations. So in India, the same standard has been adopted as IS 1751. It's not 512. I'm sorry, I made a small mistake while typing a little bit faster. Electrical installation, medical locations. This standard has been published in 2021. And this standard is in IEC, it's made by the MT40. MT stands for maintenance team, MT40 of TC64, where I'm a member. So basically the background of the standard and why each and every part of the standards or how it is explained is well known to me. So today we are going to discuss not the entire subjects of this particular requirement, but only few of the important subjects which is related to the hospital safety. Now, medical location. What do we mean by medical location? In a hospital, there are general locations and medical locations. Medical location, when we say medical location, that is a place where a patient or a person or a human being is treated, some kind of treatments. Probably, it is subdivided into group 0, group 1, group 2 locations. But medical location means it is not the general place. It is a place where people are connected with some kind of, or people can touch some kind of electrical apparatus. So as a result, what happens, in medical location, all of you know that electricity and electrocution shock, the resistance to body is primarily given by the skin, and if any metallic part bypasses the skin, resistance is too less. As a result, the conventional calculations are not applicable. Even a small current flow probably may be dangerous to the person. It can create burns, or it can create electrocution, heart stopping and all. So Basically, in a medical location, a lot of biomedical equipment probably are bypassing the skin. As a result, very low resistances are applicable. Shock chances are much more. Also, shocks such as micro shock and macro shock, especially happening because of different electrical biomedical equipment connected to the area. Plus, the area is wet. Once when your body is wet, the resistance is less. As a result, the chance of shock is much more, or chance of burning is much more. Then in some of the areas in hospitals, it is oxygen enriched area, means the amount of oxygen, because say for example, an operation theater, oxygen is used. As a result, the oxygen content in the area is very high. I'm sure most of all of you are aware about the fire triangle. You need fuel, heat, and something to burn oxygen. If oxygen is more, the chance of fire is more. Then one of the requirement is supply continuity during fault, which I will explain later. Plus the other requirements are EMI, harmonics, and so on. So basically, medical locations are special areas where we really need to treat people, or really need to treat the electrical appliance very specially. We cannot apply the normal rules and regulations in a medical location. So in a medical location, what is the specialty? Due to a lot of electronic, the biomedical equipment are using magnetizing or self-inductance for its operation, normal operation. So sometimes you don't need to touch an equipment to get a shock. Current flowing through the insulation itself sometimes creates some kind of shock hazard. And the conductive parts, a lot of conductive parts are existing, and probably it is also connected to the human, like direct connection to an internal organ during measurement or a surgery. Then external electrodes for temporary cardiac pacemakers, electrodes for intercardiac measures, then liquid filled catheters. Then one of the worst danger is current flowing through the heart, and all these things can create burns. That means the body can, the surface can burn, muscle cramps, respiratory arrest, cardiac arrest, and ventricular fibrillation. These are the anticipated effects or minute effects which is going to happen in a medical location. One of the important physiological effect is microshock or macroshock. So a macro shock is applicable. For example, externally applied current spreads through the body. Probably if you are touching something, or probably if an appliance, a faulty appliance is connected to your body, such accidents can happen, and it may be a reason for a cause of death. So the influencing factors here are skin and body resistance and the design of electrical equipment. So both these micro and macro shocks are very dangerous for a medical location. Now, in order to reduce the accidents or the amount of the problem, different standards are recommending different requirements. So say, for example, the NFPA 99, which is followed in America, it says in general areas under normal condition, more than 500 millivolt shall not be allowed, and in critical areas, 440 millivolt in normal condition shall not be allowed. That means you have to, all the exposed and extraneous conductive parts must be interconnected in such a way that more than this voltage does not experience between two metallic parts. The NEC 2011, NEC, I mean, this is the National Electrical Code of India 2011, Part 3, Section 4, medical locations. This particular code 2011 explains about the requirements very well, very in a detailed way. So according to this particular standard, under certain areas, a voltage of less than 10 millivolt under certain conditions is also necessary to avoid shock hazard. Similarly, the new standard IS 17510, the 1751, the medical location standard, the new one, 2020-21, clause number 6.1.3.1.1.1, disconnection of supply in group 1 and group 2 medical locations. The standard says The nominal touch voltage, the conventional touch voltage shall be lesser than 25 volt. Conventional touch voltage is not in normal condition. This is in a fault condition. That means probably you have a faulty equipment or you have a faulty electrical wiring. Under that condition, under a fault condition, the maximum allowed touch voltage in group 1 and group 2 medical locations are lesser than 25 volt, or before the voltage reaches 25, we are supposed to disconnect the supply. The table 1 of the same IS standard says for general location, we are supposed to use a TN system, the disconnection times are given. Also the IT system disconnection the disconnection times are established. This means you should, if you carefully look into this particular table, what is missing is a TT system. So we are not supposed to use a TT system in a normal application. TNS is recommended in IS 17512. I'm sorry that I have put as 17510 as somewhere. That is mistake. 17512 is the correct standard. So basically, TT systems are not recommended in the medical locations or in the hospital. We always have a confusion. What exactly is this, the TN system or TT system? Because, for the safety, the first point is what kind of system earthing you are doing. Now, with respect to safety, system earthings are classified into two. The first one on the left side is an electrical installation where safety is achieved by disconnection of supply. Disconnection of supply in the sense, in case of any fault, the supply must be disconnected within certain time. Before the touch voltage is harmful to a human being, the supply must be disconnected. This is the safety measure number 1. It can be used in general locations, and this is also called as the earthed power supply. The application number 2, continuity of supply. What does it mean is, in a hospital, especially in a group 2 medical location where operations or the patient is connected to various biomedical equipment. Imagine you are putting a new device into the circuit which is having a faulty. Without knowing the problem, you have put the device into the circuit and the MCB tripped. So if disconnection happens in that kind of an area, the patient will be in danger because the supply itself has been disconnected. For that application, especially for application in group 2 medical location, continuity of supply is important. What do we mean by continuity of supply? Continuity of supply means even if you use a faulty equipment or even if there is a first fault, the supply shall not disconnect. The supply shall continue. So also, for fire services, for firefighting systems, also you can use for the technique called as fire, continuity of supply, which is called as unearthed system. So basically, electrical systems are classified into earthed and unearthed system. Earthed system means your MCB should trip immediately. Unearthed system means your MCB need not have to trip during the first fault. So with this understanding, I'm showing you a picture which is a TNS system. I'm sure most of the engineers are, those who are attending are engineers with a medical background. I'm sure they know how the system is implemented in a typical hospital. What I am showing is a TNS system. Means you have a source. The source can be a DG or the source can be a transformer. You have the 3-phase coming from the transformer. You have the neutral, which is also distributed into your electrical installation. Now, what you should understand is, you look at the picture, the green wire electrical installation is connected back to the neutral of the source. So this is a TNS system. Basically, it's a 5-wire system. And the neutral is also earthed, which is a functional bonding. Functional bonding in the sense, in order to create a stable voltage in your electrical wires to earth, a functional bonding is created. So basically, this is called as a TNS system, means a 5-wire system. Neutral shall be strictly earthed only at one place. That means strictly only at one place. You are not supposed to connect the neutral at multiple places. Then you will have bigger problems. The protective earth conductor, the fifth wire shall run parallel to the line and the neutral conductor to avoid large loops, and the fault loop impedance of each and every circuit or each and every distribution final circuits must be able, the protective device must be able to disconnect the supply. So it is not only a TNS system. TNS system in simple, people think that, okay, you make 5 wires and you make a TNS system. No, it is not like that. A TNS system followed by all the conditions of TNS must be followed. It also means our general concept, what I am showing you is a source. Imagine it is a transformer or a DG. Neutral is connected to an earth electrode in soil. And then you have your electrical installation. Imagine some kind of a load, a biomedical equipment which is connected to the power supply. The equipment vendor is asking, I need a separate earth. As a result, what people do is the body of the biomedical equipment is connected to a separate earth electrode. Actually, this is not allowed in hospitals. It looks like a TT system, but practically in my experience, the hospitals, those who are following this kind of a system, means each and every part of the electrical installation, such as some of the biomedical equipment, sometimes isolation transformer, sometimes UPS, sometimes electrical DBs, and each of the transformer and DG, 2 for neutral, 2 for body. So such system is actually not allowed in hospital, and it is completely wrong. We are supposed to follow a TNS system, a proper TNS system. Similarly, for group 2 medical location, we can also go for IT, means insulated, isolated supply with insulation monitoring devices and the leakage current monitoring system. Say, for example, IT system means you have the source, probably an isolation transformer, then the secondary side of the isolation transformer, line 1 and line 2 with a voltage of, let us say, 230 volt. These two lines are completely insulated. So these two lines are never connected to earth. So it is completely insulated. Now you have an insulation monitoring device and all this, this entire system, sometimes it's called as a hospital IT panel. So hospital IT panel for group 2 medical location is one of the several other requirements. What I wanted to tell you is, don't think that by making hospital IT panel, you achieve the entire safety. No, it is not like that. You have to have so many safety measures. One of the safety measures is medical IT system. But whenever it comes to earthing system, actually the first part which we are missing is earthing. And everywhere, so many earth electrodes. There are hospitals with more than 150 to 200 earth electrodes all around. So we make a kind of an earth farm. So earth farms are a clear violation of the safety, and it is one of the main reasons for non-disconnection of supply resulting in fire and shock hazard. Please don't make it. Also, then what you should do, you should clearly follow the rules of IS 732 and the IS 17512 to achieve safety. Also, don't believe in magic boxes. There is no magic box which can ensure electrical safety. What I mean to say is, in the market, 2 weeks back when I was visiting a hospital, they told that they have bought a new product which will offer all kind of electrical safety. Whatever safety you need, this particular black box offers it. So actually, these such black boxes cannot offer any safety. Please don't follow such things. You should follow all the each and every rules and regulations of these particular standards. Also, a lot of hospitals are doing thermography in the final wirings to ensure electrical safety. But in the last slide, I will explain you what kind of testings are required. Thermography, unfortunately, is not recognized for low voltage electrical installation as a reliable testing measure. Then what do we need for earthing? As I am showing in this particular picture, the correct way of earthing is called as main equipotential bonding, supplementary equipotential bonding. main equipotential bonding, as you can see in the main, in the picture which is at the center, at the mains incoming panel, we are supposed to make an earth bus bar, and the exposed and extraneous conductive parts must be connected to this particular bar. Then at the sub node, let us say, for example, operation theater, you are supposed to have supplementary equipotential bonding. On the left side, you can see how the supplementary equipotential bonding is made. You have to have a bus bar larger enough to accommodate each and every connection separate. So individual earthing means each and every medical item must be connected to this bus bar separately. This means you are not supposed to make a loop. Then you can see here your some of the biomedical equipment are connected. The medical IT system is connected to the bus bar. The cable management system is connected to the bus bar. The floor mats, electrostatic mats, or some mats, if it is available, is also connected to this particular bar. The lights, the monitoring system, and whatever the medical gas, the other extraneous conductive parts such as the wash basin or whatever, all the metal parts in that location is connected to a common bus bar, and this is called as supplementary equipotential bonding. One of the first and the foremost electrical safety requirement in a medical location is to have a supplementary equipotential bonding. In the picture, I am just showing how to make it, but there are several rules to be followed. Say, for example, after making the supplementary equipotential bonding, let us say, for example, this particular medical pipe, the gas pipe and the bus bar, the resistance between the medical pipe and the earth bus bar must be lesser than 0.2 ohm. So measurements are required, the joint measurements are required. So basically, the rules for supplementary equipotential bonding is very much mandatory for medical medical locations, group 1 and group 2 medical locations. Please don't follow the medical equipment vendors' claim for having separate earth electrodes. Separate earth electrodes are wrong. This separate earthing, if they claim, is something like from their equipment to the supplementary equipotential bonding, you need a separate wire. So this is much more efficient, and of course it is very much cost saving, very much economical. So this is what is recommended in this standard. Now, medical locations are classified into group 0, group 1 and group 2 medical locations. So group 0 medical locations where medical electrical equipment can be brought into contact with the patient or need to be touched by the patient, but basically the applied parts are not intended to be used. Medical locations where no applied parts are intended to be used is called as group 0 location, but it doesn't mean that the person is not allowed to touch the electrical appliance. Yes, of course, that is allowed. Now, group 1 means a location where medical equipment is used externally, the applied parts are used externally, and the group 2 means the medical, the applied parts are used internally, means sometime, it is bypassing the skin and the equipment are going into the body. As I said, once when the skin is bypassed, the resistance of the body is quite less, so you have to be very careful. So the first point is the medical locations are grouped as per this particular group 0, group 1 and group 2 medical locations in the standard. The next is the applied parts. Applied part means the part of that particular medical equipment which finally is connected to the body of a person. So there are earthed parts, earth insulated parts, and earth insulated parts floating. Earth, that means you have the applied part. It can be an earthed applied part, unearthed applied part, completely insulated earthed part. Anyway, this is the responsibility of the medical equipment vendor. You don't need to be bothered about this particular thing, because the medical equipment vendor, according to he has to categorize his equipment according to this particular requirement. But when it comes to the electrical installation, what is required is I'm showing you the table B1 of IS 17512/2021, examples for allocation of group numbers and classification for safety services in medical location. So here on the left side, you can see some typical examples. For example, massage rooms, what you should do, delivery rooms, how to categorize. Say, for example, anesthetic room, it is a group 2 location, operation theater is a group 2 location, then heart catheterization room is group 2 location. So basically this table B1 of IS 17512 will give you an idea of the categorizations group 0, group 1 and group 2. Please note that this standard can be downloaded from the Bureau of Indian Standards website at free of charge. So you can download it, and it's only a few pages. It is not a very big document. It is only few pages, probably 20-30 pages. You can go through it. But please also be sure that this IS 17512 to be read along with IS 732, because I would say it is a sub standard of IS 732. You should read both the standards. Now, the National Electrical Code 2011 also gives you some indication of the kind of protective provisions required in a hospital, in a medical location. However, the NEC will be replaced, 2011 will be replaced by probably an NEC 2022 within 2-3 months. But I would recommend that this provision of NEC 2011 also can be followed, because it gives information a detailed information is provided. So different safety provisions are recommended in the standard, starting with P0, P1, P2, P3, P4, P6. You can see it here, different provisions, and the explanations are provided. I will just read P0, P1, P2, and P3. P0 means duration touch voltage restricted to a safe limit. This is by installation, TNS, TT, or IT system. But as I said, nowadays TT is not recommended. TNS is recommended for medical location. P1 is P0, touch voltage patient environment restricted to a safe limit. What does it mean? It means the touch voltage is lesser than 25 volt. P2, additionally, the touch voltage is reduced to less than 25 volt. Resistance between extraneous conductive parts and the protective bonding conductor bus bar of the room shall not exceed 0.1 ohm. Now, in the new standard, this has been little bit modified to 0.2 ohm. But this how to measure is also equally important. If you take a multimeter and measure the continuity resistance, of course, you get erratic values. You have to have a very good, high quality micro ohm meter to make this particular measurement. Then P3, I don't want to read much into it. So different protective measures, provisions are recommended in the National Electrical Code 2011. So additional protective provisions. I'm just showing you just to give some information to you. This NEC 2011 also is freely downloadable. You have to go to the BIS website, make a username, password, and you can download it. Of course, NEC 2011 is a big document. You have to go to Part 3, Section 4, medical locations. Now, the same standard explains you with respect to the recommended protective measures for each and every application. The hospital is categorized into various rooms. What kind of the provisions necessary for each area, P1, P0 to P7 is also provided in the standard. Say, for example, anesthetic room, P1, P2, P0 and P1 is mandatory. P2 to P5 you can make as an additional safety provision. So I skip these slides because sometimes, in a presentation, making it too much theoretical or theory will be too much boring. So you can download it and you can read it. Please try to understand it. Then in the new standard, the IS 17512 special requirements for group 2 medical locations. Here, the requirements are very much, modified. The first thing is you need to have a medical IT system in group 2 medical location. The requirements are given in this list. Once when I share the video or once when I share the presentation, you will be able to understand and you will be able to read it more. What we will do extra is we will make a blog in our website, and the blog also will be shared to you. As a result, you will be able to understand and you will be able to download all these documents. So here, medical IT system, the internal AC impedance, the test voltage, and all these requirements are given. Then again, medical IT, in case of fault, in case of a single fault, what you should do, or in case of any insulation resistance reduction, what is necessary is also very well documented. Now, the other requirement. So far the last 2 slides I was showing about the requirement of medical IT system. That means the OT panel, which you generally call, is one of the safety measure. But the additional safety measure is the ME and the ME system. Medical equipment and medical equipment system shall be designed and tested as per IS 13450. This is a new standard. It is, of course, from the IEC standard. Please ensure that all the medical items which you are buying and using in your hospital, they are conforming as per the IS standard. You can also refer to the respective IEC or sometime, European products, the EN standard, but check that it is equivalent to the IS standard. Then on the second para, what you are seeing is these systems, the medical equipment and medical equipment system, once when you put a new system into your electrical installation, or if you do a repair or maintenance or some kind of reconnection, you are also supposed to do a testing as per IEC 62353. There is no equivalent Indian standard yet. So this particular standard, what does it says? You are supposed to test the resistance of protective earthing. Means you have from the equipotential bonding bar to your equipment, you have a wire, earth wire. The resistance of that wire must be lesser than certain limit. So you are supposed to measure it. Measuring of insulation resistance is required. Then equipment leakage current to the equipment and applied part. These 3 measurements are mandatory in every biomedical equipment or ME and ME system after you, or once when you connect or reconnect into your system. The next requirement is oxygen rich environment. So as I said, oxygen rich environment, the chance of a major fire is very high. So medical equipment used in that area must satisfy lot of special and specific requirements, such as the temperature of the material is rise to ignition temperature. No, before that you are supposed to disconnect all these things. So these requirements are necessary under normal condition or single fault condition. What is single fault is, an appliance is faulty. Even under that condition, these requirements must be met. Similarly, the additional requirements for oxygen enriched areas, it is not 1 or 2 requirements. There are several requirements. I don't want to read all the requirements to you, but as I said, I will put it in the blog. You can download it, and if in case of any questions, you can get back to me. We can have a discussion, or I can explain to you. Again, additional requirements of medical equipment in oxygen-rich areas are also shown. So what I wanted to tell you is designing a medical location, electrical installation in a medical location is not that simple. You have to understand the standard, you have to understand the requirement of each and every requirement, and you should do it properly. And the final part is testing. In any hospital, the testing which is recommended in the IS 732 for general locations is very much mandatory. There are 19 inspection points and about 10 testings. Of course, there is one more which is called as a PAT, portable appliance test. These tests are very much mandatory. And for the medical location, as I said, the additional safety features are required, such as a TNS system is mandatory. That means the person who is doing, he should be able to find out, he should be able to understand what is TNS, and he should check and find out the integrity of TNS system. Automatic disconnections are necessary. Then special requirement for group 2 locations. Then the touch voltage under normal conditions need to be tested. Then the current loops say for example, once when you operate some equipment which is creating a kind of leakage current, or sometimes some kind of electromagnetic influences, parallel paths also may have a current flow which can create problems. So all these things must be tested. EMI has to be under control, otherwise unnecessary your electrical communication system will create problems. And the last one for medical location is additional test. In the normal electrical installation, you need to have the 10 different tests, and the medical location, you need to have the additional test. The first one is the functional test of medical IT system. Then the second and third are related to the equipotential bonding, supplementary equipotential bonding, and main equipotential bonding. Then the changeover system, you need to check whether leakage currents are within the limits and so on. So all these additional safety measures are also necessary. So what I wanted to tell you is, or what I wanted to convey is, safety in medical location, it is not achieved by by implementing one measure. There are several measures. So all these measures must be implemented in order to achieve safety. Now, what we offer in CAPE, we are capable of offering the entire solutions, starting with the risk assessment as per the ISO 14971, which is actually, in medical areas, there are chemical things, biomedical things are there, wastes are there, how to handle it, and in case of accidents, how to solve the issues are included in the ISO. In this particular ISO, you have to make a risk assessment. Implementation of TNS system with the protective equipotential bonding and supplementary equipotential bonding. This we are doing already in several hospitals. We carried out this. Medical IT panels for group 2 medical locations, because once when we offer all the services, medical IT panel is also one of the requirements. So this also we are offering. Then periodic verification and training of biomedical engineers. What we are doing is periodical verification. Sometimes you may have to check your UPS and your generator once in 3 months or once in 6 months. So calling somebody, a third party, and doing this test will be quite difficult. Also, imagine you are having a new equipment every time. Depending on a third party will be very difficult. So we train your engineers, or we train your biomedical engineers to handle the day-to-day needs of the technical requirements. Compliance to IEC 62353 for medical equipment and medical equipment system. Then EMI and protection against temporary over voltages. As you know, most of the time the electronic equipments are failing due to small issues. If those small EMI issues are handled well, you will get the life of the equipment will go very high, and without any accident you can enhance the life of the equipment. And the compliance to the standards IS 732 and IS 17512 can be made. So these are the safety measures which we are offering. Then we have made a website. Actually, we are working on a kind of artificial intelligence, AI in electrical safety, which is probably very new. We are working since last 1 year. People ask how AI can help in electrical safety. Of course, we are building up a large database. This large database will have, let's say, for example, a client or an user wanted to know why the MCB didn't trip. A simple question. So once when you log in, once when you ask this question to this software, the software tells you, okay, there are 10 reasons, and it will ask maybe 1 or 2 questions. And if you give some simple answers, the software will be able to tell you exactly what is the problem with which the MCB didn't trip. Similarly, we are trying to make it mostly for the investigation purpose. Whenever there is an accident, the investigations can be done with this particular software. We are working on it already last 1 year. So AI in electrical safety. And we have made a website specifically for that, which is called as SOLVE. SOLVE stands for Safe Operation of Low Voltage Electricity. solvelv.com is the website. You can go to the solutions. You can go to the sub page, which is special locations. You can find the special services available. and the medical is one of the special location, and you will be able to find out the requirements of the medical location in our website. So you can go to it, and this website will be useful for you to understand some information. But parallelly with after this program, we will probably tomorrow or day after tomorrow, we will make a blog exclusively with these requirements so that it will be more clear to you. So by this, I would like to stop my presentation. Thank you very much for listening to me. We actually have a large group of people, more than I think 180 participants are there. So thank you very much. Over to you, Mr. Dominic. We can go for a question and answer.
Yeah. Thank you. It was a quite short presentation, as normally we take 1.5 hours. But very insight information that you have given, Kumar, about how to solve the issues of the current hospital and how CAPE can help the healthcare industry in solving this problem. So